Okay, we're looking at a gear here where I've got a motor A that has an angular acceleration given by 4t cubed, where t is in seconds. Okay, if it's initially at 20 radians per second, determine the angular velocity of B when t equals 2 seconds. Okay, so we'll start this one by essentially integrating my alpha to get omega because I want the angular velocity. So I'm going to convert everything to the angular velocity. So to do that, again, you just take that alpha equals d omega dt, do an integral, okay, integrate dw. Again, my initial is 20, so it's 20 to some angular velocity. Then equals the integral of alpha dt from 0 to t, where alpha is 4t cubed. And then from that, I get that the equation for the angular velocity of gear A to be t to the fourth plus 20. Okay, plugging in 2 seconds for that. 2 to the fourth is 16, so 16 plus 20 is 36 radians per second. So after 2 seconds, that is the angular velocity of A. Now I want to find the angular velocity of B. To do that, again, I use the velocity at the edge point, meaning that at this gear at the edge, the velocities have to be the same, which means that the radius of A times omega of A equals the radius of B times omega B, which is what I have down here. So this is the velocity of a point at the edge of A. Here's the velocity of a point at the edge of B, and those have to be equivalent. So solving this for omega B, I know my radii. I know omega A. I can find omega B to be 12. So again, I just use the kinematic equations that are similar to my linear kinematic equations. And then I use the fact that the velocity at the edge point of the gears have to be equivalent in order to figure out the ratio of the angular velocities.